Hello, everybody. This is Mahesh Vyas from CMI. A warm welcome to all of you to join this CMI research webinar on a very important topic, on a very well-received paper. We will begin very soon as people are still streaming into this webinar. So this is a paper by Sutirtha, Sinha, Roy, and Roy van der Weide, from the World Bank. The paper is titled as Poverty in India has declined over the last decade, but not as much as previously thought. An interesting paper. The paper has made waves already all over the place. It has been, I think, the most definitive kind of answer to what has happened to poverty in India. It has dealt with the CMI CPHS database quite robustly to deal with all its perceived shortcomings, to make adjustments, to make it comparable to the NSSO's older database and methodology, and then come to conclusions. We have a fairly nice presentation being presented by the two authors. And we have Anup Malani from University of Chicago, who has made several presentations on this platform earlier as a discussant. Without much ado, I will pass on for the two Roys to tell us about their work. Sutirtha and Roy van der Weide, please take over.
Thanks a lot, Mahesh. Let me share the screen. Host disabled participant screen sharing. Can allow the. Okay, now I can do it. Let's use the PDF. Okay, is it visible?
Yes, it is.
Okay, great. So thanks a lot again, Mahesh. Appreciate this chance to present this work. So we basically have three modules. The first module of the presentation is about reweighting. Thanks. The second one is about the two approaches that we use in our paper. And then the third is where we talk about our main results and present some validation exercises. So what we can do is we can pause between the first module and the second module, and the second module and the third module. So right after reweighting and right after the two approaches, and we can review the chat screen to see if there are any questions, and we can address them right then and there before we move on to the next module. And then thanks to Anup, Anup can come in at the end, and we look forward to his inputs and his guidance. So Roy is going to go first, so all yours.
Okay, thank you very much. So as you all know, the objective of this project has been to obtain estimates of poverty for India in recent years that could be compared to estimates of poverty that were to sort of the most recent official estimates of poverty that date back to 2011. So the challenge that anyone would face to estimating poverty in India is that the official household survey, the NSS Household Consumption Expenditure Survey, that typically underlies India's official estimates of poverty, was last made available in 2011. There has been a survey, as you know, conducted more recently in 2017, but the microdata of that survey was never made public. And so so for anyone then who wishes to produce estimates of poverty, will have to find alternative ways of estimating poverty. The World Bank routinely sort of addresses challenges of this kind by appealing to national accounts data, and it works with it estimates the household sort of consumption distribution for the last time microdata was available, so 2011 in the case of India, and it then looks at growth rates of in consumption from national accounts data. It works out the relationship between growth in national accounts and consumption growth observed in household consumption surveys. And then it uses that to move the entire distribution forward. So, for example, if the pass-through rate between the growth rates observed in national accounts and the growth rates in household consumption data is estimated to be 0.7, for example, and we observe a 10% growth rate in national accounts, it would imply roughly a 7% growth rate in mean average, in mean household consumption data. And so the whole distribution is moved forward. And I say the whole distribution because national accounts doesn't really give you any additional information that would allow you to infer how inequality might have evolved over time. And so one is forced to make the assumption that the dispersion in household consumption has remained unchanged. So the whole consumption distribution is moved forward. So that's an alternative approach that the World Bank routinely adopts in cases where they wish to estimate poverty for a point in time and there's no household survey available for that point in time. Typically, however, the household survey data would be 2-3 years back, in which case the approximation errors that one inevitably will have to incur with this type of approach wouldn't be too much of a concern. In the case of India, however, it has been now 10 years. And so that approach is not ideal anymore. And so that prompted us to adopt an alternative source of data to estimate poverty. And in our case, we embraced the CPHS survey data collected by the CMIE. It's as you all know, that survey data was first collected in 2014-15, and every year since then, it is the sample size is roughly 170,000 households. Households are interviewed up to 3 times per year. The consumption data is collects data using a recall of the past month expenditures that were for the households. To make it more comparable to the way data was collected by the NSS in 2011, what we do is, in the event households are interviewed multiple times per year, up to 3 times per year, we randomly select one of the interviews for that household, as that would make it more sort of readily comparable to the NSS data collection. In addition to, so this is the first time we'll have a new survey that actually collects household consumption expenditure data since the NSS 2011. In addition to that, the CPHS survey also collects a rich set of household characteristics, demographics, education, employment, dwelling characteristics, household asset ownership, and so forth, which we also take advantage of. There are, however, 2 challenges in working with the CPHS survey. That the first is that it has been observed that that there is some lack of representativeness in the CPHS survey. There is a paper by Dresse and Sumanchu, for example, that sort of carefully document the ways in which the CPHS survey data lacks certain amounts of representativeness. So that's one challenge that we carefully take on, and we make a concerted effort to address that. And we do that by making adjustments to the sampling weights in the CPHS survey. The second challenge is that once we establish the national representativeness of the CPHS survey, the second challenge is that the household consumption expenditure data that is collected by the CPHS is collected by means of its own household questionnaire that is different from the consumption expenditure questionnaire of the NSS. And that means that without making necessary adjustments, these 2 measures of household consumption cannot be readily compared. And so if we want to compare our estimates of poverty derived from the CPHS survey to estimates of poverty that date back to 2011 obtained within the NSS survey, we'll have to account for that divergence. And that is the second challenge that we're going to tackle. In this slide, we briefly highlight the ways in which we observe some issues with representativeness of the CPHS survey, building on the work by Dresse and Sumanchu. So, for example, we see that small households are overrepresented in the CPHS compared to other nationally representative surveys for India. We see that households with low educated members are severely underrepresented in the CPHS, and so forth and so forth. we address this issue by identifying a number of nationally representative surveys that are contemporaneous to the CPHS survey. We also identify a set of benchmark variables that are for which statistics can be computed both in the CPHS as well as these nationally representative surveys. Think of the labor force survey and the NFHS surveys. We then use those benchmark surveys again that are assumed to be nationally representative, and those benchmark variables to make adjustments to the sampling weights in such a way that at the state, urban, rural level, we're able to match the statistics for those target variables. Think of statistics on demographics, education, employment conditions, etc. We deliberately will hold out some data and some benchmark variables to validate the reweighting exercise. So using our selection of benchmark variables, we make adjustments to the sampling weights, targeting statistics at the state/urban-rural level. And then after these adjustments to the sampling weights have been made, we inspect the statistics for the variables that we deliberately held out to confirm that the adjusted weights sort of establishes representativeness for those variables as well. Having up to this point, we haven't inspected the household consumption data that's collected by the CPHS survey yet. So we established representativeness by targeting demographics, education, employment, and so forth. Here, what we're going to do is we see that after we reweight, what does that mean for the distribution of household consumption data? In this particular slide, we show you estimates of the variance of log household consumption and estimates of the third moment of the consumption distribution. And we compare for the CPHS income distribution, sort of consumption distribution, and we compare that to estimates of the variance and the third moment of the NSS consumption distribution back in 2011. So the dotted line, that orange dotted line, represents the estimate of both the variance and the third moment obtained from the NSS 2011 distribution. It's a bit deceiving, perhaps, that this suggests that we have estimates of NSS for all the years. That's of course not the case. The dotted line represents the estimates for 2011. Also note that that line is not strictly constant. And the reason for that is that at any given year, we try to make an apples to apples comparison. So in the early years, for example, there were a couple of states that were not part of the CPHS sample, but that were covered by the NSS. And so at any given year, what we do is we make sure that the states covered by both of the surveys are identical. So if in the earlier years, some states were not covered by the CPHS, but they are available in the NSS 2011, we drop those states from the NSS. And as those states enter the sample in the CPHS sample further down the road, those states are entered again. One thing you can see here, the blue line are the estimates we obtain using the original CPHS sampling weights, as well as the original CPHS household consumption data. The red line is what we obtain working with our adjusted weights. Again, the adjusted weights establish representativeness in terms of demographics, education, employment, and so forth. But when we inspect the household consumption distribution, clearly there are still some differences. The reweighting closes the, well, one thing maybe we should note here is that the CPHS consumption distribution is notably less dispersed. So sort of inequality in household consumption is much lower in the CPHS than it is in the NSS. And the third moment is also much lower. So the CPHS consumption distribution is much more symmetrically distributed than the NSS consumption distribution is. The reweighting helps close the gaps in the second and third moment to some degree, but not fully. Especially in the third moment, even after reweighting, the gap in third moment remains very notable between the CPHS and the NSS distribution. We argue that an important reason for this difference is the fact that the CPHS survey has its own consumption questionnaire, its own household expenditure questionnaire that is different from the household consumption questionnaire in the NSS. And as a result, they result in different measures of household consumption. And so that's the second challenge that I alluded to earlier, is we're now going to make an effort to introduce into the CPH survey a measure of household consumption that is of the NSS type. That if we were to derive estimates of poverty and inequality derived from them, that it would allow us to make comparisons with estimates of poverty and inequality that are available in NSS 2011. We're going to consider two approaches.
Let's just pause and see.
Sorry, I forgot that this is the moment where we're going to take a pause. If anyone has any questions, and I see 5 questions were.
We couldn't understand the first question. Can you give on poverty income for a year? Okay. Can you define the poverty line in simple language? Again, I'm thoroughly familiar with the literature.
Yeah, poverty line in simple language. So the poverty line, in a way, it defines a basic needs basket conceptually, and it evaluates the price one would have to pay in order to obtain such a basic needs basket. Conceptually, that's what a poverty line measures. The $1.90 poverty line that we're using in this presentation is the global poverty line the World Bank adopts for measuring extreme poverty. Is CPHS data publicly available without payment?
This is probably a question for Mahesh.
That's a question for Mahesh.
It's available publicly, but is available only for a price.
Can you live on poverty income for a year? By the way, I'm thoroughly familiar with the literature.
Okay. I don't know what to say about that. Slide 7 to measure moments NSS 2011 is multiple. How is this possible? Yeah, so we clarified this. This is actually NSS 2011. We're just putting it on a graph so that you can compare the different moments across years.
Yeah, so we're not measuring NSS statistics over time. The dotted line represents estimates for NSS in 2011. Not sure I understand why the variance was calculated from the NSS from. Is this the same question? Same. Okay, so if there are no further questions, is there a?
Yeah, there's something. Let's just see.
So the reason why NSS changes over time is because the number of states covered in the CPHS sample evolves over time. Most notably, number of states, so the states covered by the CPHS becomes larger over time. And so in order to facilitate apples-to-apples comparison, what we do in any given year, we say in 2015, we check, okay, what states are covered by the CPHS in that year? There will be a couple of states that are in the NSS 2011 for the year, but not in the CPHS. In that case, we remove the states from the NSS survey that are not yet into the CPHS sample. But then say in 2018, a number of states were added to the CPHS sample. And so in that case, we reintroduce those states into the NSS survey, which is why the estimates slightly change over time. But in all cases, we use the exact household, the exact same NSS 2011 household expenditure survey. Okay, I think this covers the questions up to this moment. So as I indicated, we're going to consider 2 approaches that will, so just to recap, at this point, we have made adjustments to the sampling weights that effectively convert the CPHS survey into a nationally representative survey, which means that the first challenge is satisfactorily resolved. The second challenge is that we are going to make an effort to impute into the CPHS survey a measure of household consumption expenditure that is more readily comparable to the household expenditure variable that is available in the NSS 2011. The first approach we're going to adopt is we're going to build a model that's a little bit in the spirit of Tarossi's work during the first Great Indian Poverty Debate, for those of you who are familiar with his work, where log household consumption per capita, and I refers to household I, is modeled as a function of a set of sort of predictors of household consumption. And you should think of demographics, education, employment, dwelling characteristics, asset ownership, etc. And these are characteristics that are available both in the CPHS and the NSS. That allows us to estimate this model in the 2011 NSS survey, where we respect the non-normality of the residual, the error term. So we adopt a a non-parametric approach for the error term. We take our estimates obtained in the NSS 2011, and we take our estimates of that relationship to the CPHS years, and then impute NSS type household consumption expenditure into each of the CPHS years. So the variation in the consumption distribution in this case then is going to be driven by the fact that there will be variation in demographics, education, employment conditions, dwelling characteristics, etc. over time. Should we note that in this particular approach, the actual household consumption expenditure data that is collected by the CPHS is not utilized in this first approach. So in this slide, we take stock of what that does, to what extent that helps us close these gaps in the second and third moment that we presented earlier. And in this case, we divide India into urban in India and rural India. Again, the dotted line represents the estimates obtained in the using the NSS 2011. The blue line in this case is obtained using the CPHS consumption data, but all estimates reported here are obtained using the adjusted weights. So again, the blue line is obtained with adjusted weights. So we're dealing with a nationally representative CPHS survey now, but it uses the household consumption expenditure data as collected by the CPHS without making any adjustments to it. The red line is the imputed NSS type consumption that comes from approach 1. So this is obtained by imputing NSS type consumption on the basis of the rich set of predictors that are shared between the CPHS and the NSS. You can see that as far as the variance is concerned, this does a pretty good job in closing that gap. In rural India, in the earlier years, you could see that when using the original CPHS consumption data, the variance was notably smaller, the dispersion was notably lower than what we observe in the NSS. But that gap is almost entirely closed by using the imputed NSS type consumption into the CPHS. Same for urban. You can see there's quite a notable gap for urban India in terms of variance, but also that gap is almost entirely closed when using imputed NSS type consumption data. The same is not entirely true for the third moment. So it does help close the gap to an important degree, but it doesn't close it fully to the extent that we observe for the second moment. So, and that's especially true in urban India. I think in rural India, one could argue that the imputed NSS type consumption into CPS does a reasonably good job in closing it, especially for the earlier years. The gap seems to be a little bit larger for recent years, but in urban India, the gap is still quite large. There is a marginal reduction in the gap of third moments, but even after reweighting and even after imputing NSS type consumption using approach 1, we still observe a rather notable gap in the third moment. That's partly what motivated us to also consider approach 2. And approach 2 fully embraces the household consumption expenditure data that is collected by the CPHS. And in a way, it is a version of approach 1, but our sole predictor in this case is of NSS type consumption is the CPHS consumption data. And one would expect that to be a very strong predictor for obvious reasons. Notice that in this case, however, the log NSS consumption is on the right-hand side of the equation, whereas in approach 1, that was on the left-hand side of the equation. And that is motivated based on the empirical stylized facts. So as you will have observed, is that log NSS consumption is, when compared to CPHS consumption, shows greater deviation from normality. So in particular, it has a much stronger skewness than the CPHS distribution exhibits. And so we address this by putting CPHS consumption on the left-hand side and modeling it as a combination of a normally distributed error term and the sort of the log NSS consumption data that shows more pronounced deviation of normality. Now the challenge we face here is the estimation of the parameters, the intercept A, the regression coefficient B, and the variance of the error term sigma. And the reason why this is not obvious is that we obviously don't have a sample of households for which both measures of consumption are observed. If we did, then this would be a very simple regression. But given that there is not, we have to find other ways of estimating the parameters from this relationship. And what we opted to do here is employ a method of moments estimation strategy. So we have 3 parameters, which means that we need to have at least 3 moment conditions in order to obtain identification. And what we do here is we simply use the first 3 moments. So we evaluate the expected value on both sides of this equation, right? So the expected value of log CPHS consumption equals A plus B times the expected value of log NSS expenditure plus 0. We do the same with the variance, and we do the same with the third moment. We evaluate it on both sides of the equation. That ultimately gives us 3 moment conditions. And given that we have 3 parameters to identify, we have everything we need. It should be noted, however, that a third moment condition works precisely because the data deviates from normality. If both the log CPHS consumption and the NSS consumption were symmetrically distributed, that third moment condition wouldn't add any additional information beyond the first 2 moments, and we would be in a situation where we only have 2 moment conditions and still 3 parameters to identify, and so we would fail to obtain identification. But precisely because the data exhibits deviations from normality, we observe significant skewness in the log consumption distributions. That's precisely why the third moment offers additional information on top of the information that the first and second moment provide. That's why we are able to obtain identification here. Once we have identified that relationship, we of course will want to use it to convert the observed CPHS consumption data into the NSS type consumption data. That's where a second little challenge sort of emerges, precisely because the log NSS consumption is on the right-hand side of this equation and it is combined with the error term, right? So just imagine you know A, you know B, and you know sigma. For a given household I, you know what its CPHS consumption level is, but what you want to know is what its NSS consumption level would be. But that variable is combined with the error term, and that's an error term we obviously do not observe. And so the challenge here is to estimate the conditional distribution of NSS type consumption conditional on observing CPHS consumption, which is akin to a deconvolution problem. It so happens that I have a paper with a co-author, Chris Elbers, that dates back to 2014, where we have a lemma 2 in that paper, that does exactly that. I won't delve into the details, but for those of you who are interested, lemma 2 in that paper gives you the expression for this conditional distribution under the assumptions that we're making here. Let us also share with you which moments are obtained from what data sources. And before I do that, maybe let us briefly run you to this slide here. So what we plot here is the third moment that is estimated from the NSS consumption distribution, dating back to the late 1980s. Maybe ignore the 2017 estimates. Those estimates are derived from the leak NSS survey. Since 2004, it so happens that the third moment in the NSS consumption distribution is relatively stable. And so we're going to utilize that empirical observation as follows. The parameter B in this regression is basically the ratio between the third moments in the distributions, and then to the power 1/3. Since the NSS distribution, since this third moment is comparatively stable in the NSS distribution, we're simply going to take the third moment observed in the 2011 NSS. And then for every CPSS year, we use the third moment observed in that particular CPSS round, which is notably less stable. We've also used the third moment estimated from the 2017 NSS, where we basically do not have to observe that it is stable over time, but it gives qualitatively similar results. Once we have B, we can work out A and our estimate for sigma square, which involve the first and the second moments. Now, the first and second moment are obviously not stable over time, and we're not going to assume that. But fortunately, recall from approach 1 that the imputed NSS type consumption into the CPHS does a pretty good job in matching the first and second moments. So we're going to estimate the first and second moments from the imputed NSS type consumption that comes from approach 1. and B is estimated by using the third moment that is observed directly into the NSS distribution. So no imputed data sort of is used there. I think this sort of covers the methodology as far as approaches 1 and approach 2 are concerned. So maybe this is another good moment to take stock of some questions you may have. Not sure I understand why the variance was calculated from the NSS for variation. Sorry, I have to go back to the question.
Go to this one.
Where is the first? This one? Can you define third moment of truth?
No clue what that means.
Not quite sure what that question means. Can you identify which basic needs are met with the poverty level? Can we since that question does not directly speak to the method, so it's questions that don't speak to the methodology, we'll take note of them, but we'll try to cover those towards the end of the presentation. Your poverty line is okay. Let us have a two-way debate. You can bring all your. So it seems that the skewness of consumption is much higher in the urban NSS compared to the CPHS, correct? That may result in underestimates of poverty. That may result in underestimates of poverty. Yeah, so it is important that we get those moments right. That's precisely what motivated us to adopt approach 2 in our paper. Which I appreciate the effort to compare it to NSO 2011. However, we are taking one fact. That is absolutely correct. So yeah. we're not using estimates of the first and second moment from the 2011 NSS. So that's a good point. We estimate the first and second moment by imputing NSS type consumption into each of the CPHS years, and those very much vary over time, because the imputed NSS type consumption is driven by the predictors of consumption, driven by changes in demographics, changes in education, changes in employment status, changes in asset ownership, housing characteristics, and so forth. So to the extent there is growth, and to the extent that that growth is picked up by changes in education, employment, housing conditions, asset ownership, etc., then that should be adequately accounted for. The reason why, so MLE in this case would be equivalent to using OLS, or generously squares if you're making if you assume that the errors would not be non-normal, but in our case that would be equivalent to OLS. And the reason why we're not able to implement OLS or maximum likelihood in this case is that we don't have a sample of households for which both measures of consumption are observed, right? If that were the case, if we did have a random sample of households that received both the CPHS expenditure questionnaire as well as the NSS expenditure questionnaire, then we could indeed implement MLE or OLS to estimate this relationship. But the fact that we don't have that, and that households between the CPHS and the NSS cannot be linked, we're not able to implement that, and we have to resort to something like methods of moments estimation.
I don't maybe Manoj Panda can explain. I presume the matching is for nominal consumption. You can explain what you mean by that. We would be happy to take that on. Can you define the third moment of consumption?
The third moment is literally the third moment of log expenditure. So it's the expected value. So you subtract the mean of log expenditure, then you cube it, and you take the expected value of it.
Yeah. So Anmol, we have these slides how the reweighting performs with respect to benchmark indices. That's in the appendix of this presentation. I think we just have 1 hour. We can, I don't know if Mahesh will allow us to circulate this presentation. We are more than happy to, send it via email. But all of those validation exercises are also in the paper. So if you have any sort of inputs there, once you're able to review it, we would be very interested in your thoughts and ideas.
Yeah, and also if time doesn't permit on this occasion, we're also happy to sort of continue a dialogue or a discussion after this presentation, either over email or in person.
Sutirtha, if I may, just to make this announcement that this presentation will be available on the CPHS website And this is also available on YouTube. So you can also see the website separately on the CPHS website. And we'll be happy to connect anyone with the authors for further discussions. And Sutirtha has already said that Anmol can get in touch with them to have conversations further. Thanks, Anmol.
We'll move to results next.
Right. We're gonna okay. So I'm going to go through the last section, and then maybe we can hand it over to Anup, and if there's time left, take some additional questions at the end. So my first part, I'm going to talk about the main results, and then in the absence of a NSS consumption expenditure survey, try to figure out if we can sort of validate some of the trends that we are observing in our through our two approaches, whether that sort of lines up with what we know about India from other data sources. So let's start with the extreme poverty headcount. This is at the $90 line. We know that from the NSS 2011 survey based on URP, at the $90 line, the poverty headcount was 22.5. We observe that that has come down to 10.2 by 2019. The other thing to note is that the three approaches, approach 1 and approach 2, 2011 version and 2017 version. I'll just explain what 2011 and 2017 is. But basically, the three approaches yield qualitatively similar results. The difference between approach 2, 2011 and 2017 is that the 2011 uses the third moment from NSS 2011 survey, and the 2017 version uses the third moments from the unreleased CDF data that is available at the state level in the report. And because we had observed that the skewness has not, or the third moment has not really changed between 2011 and 2017, and in 2011 we would be making an assumption that the third moment has not changed, the 2017 estimates basically sort of relax that assumption even further. So coming to rural and urban splits, the first thing to note is that the poverty reduction has been more in rural areas than in urban areas. That is maybe to be expected because rural areas were starting with much higher levels of poverty headcount in 2011. And all the three approaches are again sort of yielding estimates that are not very far from each other. So that's reassuring. There are two particular periods that I'll talk about in just a bit, but just to sort of put it in more stark terms, is this period in urban where poverty actually increased by about 2 percentage points, which coincides with the year of demonetization. And then this year in rural area where in 2019, we observe a slowdown in the economy. So just keep those two periods in mind. Coming to inequality, the URP level of inequality in 2011 was 35.71 by going by Gini. And we don't observe at the India level a significant increase in or any increase in inequality in the years post 2015. When we split it by rural and urban, rural trends are more flatter, with less change, and the endpoint to endpoint comparisons would suggest that there is not an increase in rural inequality either. Whereas in urban, we observe that in 2019 there was an uptick, a marginal uptick compared to 2011. So again, something that I will allude to later. One disclaimer about the inequality numbers that we are presenting here is that whether CPHS, whether NSS, or any other household survey will most likely cover up to maybe the 95th or the 96th or the 97th percentile of the distribution, but it'll surely sort of not be able to capture fully the sort of right-hand side of the welfare distribution. So for example, all these unicorns, all the new billionaires would probably not be represented in these surveys, whether that's NSS or CPHS. And to the extent that we expect inequality to be higher given these extreme incomes, that is consistent with the result that we are proposing, because those individuals are just not represented in either NSS or CPHS. And if we were to sort of think about these top incomes, I think what we would have to do is rely on some of the methods that Piketty and other co-authors have sort of developed over the years. So this graph is what motivated the title of the paper. So what you see here in the blue line is all the poverty rates from actual surveys, NSS surveys over the years. And then the dotted line is what the World Bank would usually do, and has been doing for India in the absence of surveys, but also in other countries, which is to take the 2011 consumption distribution and then take the HFCE growth rate from national accounts, apply a pass-through to it, and just assume distribution neutrality and push the distribution forward by that fraction, by that percentage number. And so if we followed that, the usual practice of what we have usually done, we would expect a 7.2% extreme poverty headcount in 2019, whereas the methods that we have outlined in this paper would yield a 10.4 poverty headcount rate with certain sort of year-on-year trend, especially around 2015-16, where there would be a divergence from what we would expect from extrapolation based on just national account data. Coming to inequality, again, similar story. I think we don't see an increase in inequality post 2015 consumption inequality. Okay, so this is the last part, and then we'll pause. In this next few slides, what we'll try to do is all the trends that we have observed on poverty headcounts year on year, as well as the changes in inequality that we have seen over the year post 2015 relative to 2011. We will try to validate using other data sources that are available, and also see if we can sort of validate the mean consumption value that is implied by our two imputation methods. So let's start with the first observation that post 2015, we see the fastest poverty reduction rates in the years of 2017 and 2018, and then a moderation in 2019. So one way to sort of verify this would be to look at, for example, real rural wage growth from the Labor Bureau. And there what we see is that in 2016, the real rural wage growth was about 0.9, which is associated with a reduction of about 2 percentage points poverty reduction. But then rural wage growth was as high as 3% in 2017, which resulted in a very fast poverty reduction of about 5 percentage points. And then as rural wage growth tempers, poverty reduction slows down until 2019, when rural wage growth actually turns negative. And then we expect poverty to rise. And that's exactly what we see in our data, is that poverty rises by 0.2 percentage points between those 2 years. And the correlation coefficient for these two series is about 0.94. Going beyond rural wages, if you look at night lights, the story is similar. 2016-17, there was a drop in consumption, night lights data, then an increase in 17-18, 18-19, and then a further drop in 19, which is exactly the trends that we have reported on extreme poverty, how that has evolved over time. If you look at the Nielsen consumption expenditure data, which covers FMCG goods, both branded and non-branded, but also sort of mom and pop stores, but also modern retail channels, we see that there was a local maxima in around 2017, 2018 in terms of consumption growth. That's when poverty sort of falls the fastest. And then in the moderation 2019, which is again associated with a moderation in the rate of poverty reduction. The other thing that we note in our in this work is that around 2016, the period that period was a little bit dynamic. Things were moving very quickly right after demonetization. So we have two pieces of literature. One is the Geeta Gopinath Chaudhara Rekh paper, which uses administrative data to suggest that right after demonetization, there was a sharp drop, but only a few months later, there was a rapid remonetization and consumption moved up into in 2017, a few months after demonetization. And then if we look at the IHDS3 sample, which is arguably just from 3 states, but it's telling us about something. If you look at that data, between 2011 and February to April 2017, which is like just a few months right after demonetization, consumption growth was minus 0.03%. And then if you just move a few months later to May to July of 2017 and compared it to 2011 consumption, consumption was as high as 4.2. We find similar numbers. So if we restrict our sample to just the 3 states where IHDS was conducted, and compare consumption growth rate from 2015, we don't have the 2011 number as IHDS has, we would get a consumption value of about 0.5% for February to April 2017, and about 2%, if I'm not wrong, 2% for May to July 2017. So in the same direction, but lower magnitudes, likely because we are starting with a different base than IHDS. Then the third observation that we made was that inequality has likely not increased post 2015 based on this work. And to sort of validate this, we follow something that Himanshu has done in the past, and we just update that analysis is to see consumption inequality and put it into context with other dimensions of inequality. For example, wage inequality. And so that's the slide that you're looking at here. Wage inequality includes wages only from salaried and casual wage workers, not from self-employed workers, because in 2011, US actually, the Employment and Unemployment Survey did not capture information on self-employed workers. So if you look at the rural and urban wage inequality, it has fallen down relative to 2011. And we note that there is actually a small uptick in urban wage inequality in 2019, which, if you'll remember, is the trend that I had pointed out in my inequality graph. Now let's look at some income inequality. So between 2004 and 2011, we know that IHDS, the 5th decile of households in the 5th decile, were showing a significantly higher consumption growth relative to households in the 1st decile, which would suggest that there was an increase in inequality. And NSS 2004 for those, and 2011 for the same years as IHDS, also indicated that the consumption inequality increased during that period. But if you look at IHDS 2011 and 2017, there's a fall in the income levels of households in the 5th quintile relative to the households in the 1st quintile, which would again indicate a reduction in inequality. Now, if you look at the AIDIS data, which is available for 2013 and 2018, we again detect a moderation in inequality levels, which lines up with what we are reporting. If you look at the wage growth from PLFS for casual wage workers and salaried wage workers separately, and the reason why this is informative is because you would expect poorer people to be more likely to be casual wage workers than salaried wage workers, which actually bears out in the 2011 data. If you look at households that are below the poverty line, 8% of those households had at least one member who used to work as a regular salaried employee. Whereas if you look at the top decile, almost 50% of households had at least one regular wage employee. So if you look at the growth in casual wages, it's going to it can help us inform whether there is an increase in welfare on the left-hand side of the distribution or right-hand side of the distribution. And PLFS data suggests that there was positive wage growth for casual wage workers, but negative wage growth across all these 3 periods for salaried wage workers, which would again indicate a moderation in inequality. Looking at the situation assessment surveys that were, I think, done in again 2013 and 2019, if I'm not recalling the numbers correctly, I think it's 2013 and 2019. But if you look at the land holding size distribution on the x-axis, and you look at income growth for agricultural households, you'll see that households or agricultural households that have smaller land parcels have experienced a faster income growth than those on the right-hand side of the land parcel distribution. So this would again suggest that growth on the left-hand side relative to the right-hand side. Then let's try to see if we can also validate the mean consumption that is that our estimate or our approach is sort of yielding. So one way to sort of compare the survey consumption from our work is to think about national accounts data and go by what we usually do, which is that we assume that 67% of the national accounts consumption is passed on to survey growth, to survey consumption. So if we discount the national accounts nominal consumption by 67%, we'll have an estimate. I'm not saying that that's the correct estimate, but we would have an estimate of mean survey consumption. And so we can compare our mean survey consumption from the approaches to that number. And so that number is in blue line and our estimates are in the red line, in red bars. And so what we see is that for 2015 and 2016, the mean survey consumption implied by our approach is about 3 to 4% lower than the national accounts consumption. And this is about the same sort of magnitude difference that, or at least in that region of difference that Arvind Subramanian has noted for 2011, 2016 in national accounts. Then in 2017, we close out the gap. So our estimate is very close to what national accounts would say the survey consumption is. And then in 2018-19, we overestimate. This is most likely because in those years were the high poverty reduction periods. And so it's likely that either the pass-through was more than 0.67, and therefore that blue bar is below the red line. But 2019 we surely know is a little was a funky year, because in 2019 the last week of 2019 was lockdown, March 24th to 31st, and so the effect of the lockdown is very nicely picked up in the national accounts data, but likely not picked up in a recall based measure. So when households were interviewed in April and they were asked to think about consumption in March, it might have been difficult for them to parse out the impact of lockdown in the last week. And just the final slide here, I think this is the final slide, yeah, so we can also think about not using CPHS to do the approach one that we have outlined, but instead use PLFS. And so if we have a set of, so I'm not going to get into the model one, model two. So let's just focus on model one numbers on the left-hand side. And so the left-hand side graph is shows us the poverty headcount rate. The red line, just look at the red lines, the dotted line and the solid line. The dotted line is the estimated headcount that we would get if we apply approach one to PLFS. And the solid red line is the poverty headcount at the $90 line if we use CPHS. And so you'll see that the poverty levels are very close to each other, not small differences. And then on the right-hand side, we're looking at mean consumption. And so if we use PLFS instead of CPHS, we would have about 1.5% difference between the mean consumption from the two approaches. So again, that this goes to say that this sort of lining up the mean consumption in our produced by our approaches sort of lines up with what we would expect from some of these other data sources. So we can pause here. Back to Mahesh or back to Anup.
Thank you, Sutirtha and Roy. Fantastic presentation, very intense, massive amounts of work done to process the CPHS data and then to validate the results looking at alternate sources of data. I won't take up much time. I will request Anup to please come in with his thoughts. Anup?
Thank you. Actually, can I go ahead and share screen? So if you could stop the current share.
Sure.
Yeah. Great. One moment. Okay, can everybody see the first slide?
Yes.
Okay, great. All right, thanks. So this is my commentary on Roy and Van der Weide. So let me start out by saying this is a fantastic paper. It's a rigorous paper on a really important topic. The question, obviously, that we've all been watching for the last hour and change is, did poverty decline in the last decade? It's an important period. There's been a major government change. There've been massive macro shocks, even before COVID demonetization. It's also an important question, broadly speaking, globally. A question that we've all had is, China's seen these massive declines in poverty. What's India's experience been? Another comparably sized country, huge global welfare implications. What's really interesting is that what additionally makes this important is that we haven't had good answers, I think, until the authors came along. The last available NSS is 2011, 2017 was leaked. But again, there's a big gap. CPHS, which I'm a big fan of, starts, I think, well in terms of settling down its sample only in 2015. So we've got this big, gap between 2011 and 2015. Alternative data, there's plenty. The authors review that quite extensively, but it's spotty because it's not consistent throughout. And you might wonder whether or not the data on consumption are as good. Okay. What is, I think, what makes this paper particularly special, it's not merely answering the question, but they do an extensive effort to make sure that CPHS is comparable to the NSS, and they make that available to us, both the methodology, multiple of them, compare them. They also make, I think, if I understand correctly, the weights available. That's a huge public good. And so if nothing else, we should just thank them for doing this great public service. So I'm going to quickly review the methods and then make some comments. So the paper, although the presentation had 3 parts, the paper has 2 parts. It has a methods part and then it has the results part. The methods part itself is divided into 2 analyses that are each quite sophisticated. So they have a preferred analysis, and their idea here is that they're going to make CPHS comparable to the NSS by making it comparable to other databases in the 2015 to 2019 period. And then they're going to calculate NSS comparable CPHS consumption in the later period using what they did in step 1. So basically moving CPHS close to these other databases, and then assuming that there's a similarity between those other databases and NSS, and then using that to project out in 2011 or in the later periods. So I'll go into more detail on that in a second. And then there's a robustness analysis, and the robustness analysis does several things. I'm going to quickly summarize the first of these, which is determine covariates that are overlapping between NSS and CPHS, and then predict NSS consumption from NSS overlapping covariates in 2011. And then they use this prediction model to make conjectures about or predictions about NSS-like consumption from CPHS overlapping covariates in 2015, 2019. Now that sounds confusing. I think that it's going to become much clearer if we write down some equations. I always find that equations make my life a lot easier. So I'm going to try to do that, but I'm going to be much more simple than the paper because I needed to understand exactly what their complicated methods are. Okay, so here, let me give you a broad overview of my feedback, and then I'm going to go through each of these points in detail. So the first one is, I think that it would really help the reader if they provided simple, maybe simplistic theoretical grounding for each of their methods. And so I'm going to try to do that, and they should obviously refine on that or correct me. The second is, I'm not sure whether NSS is the right benchmark or CPHS is the right benchmark. In some sense, implicitly in this paper is NSS is right. We need to contort CPHS to make it look like NSS. That's not obvious to me. I'd like to at least think about that a little bit more. So the question really here is, whatever your outcome is here, it's consumption. Which one is doing a better job of measuring the consumption that we really care about? Third is, here, the issue is not so much whether you go to CPHS or NSS. The question is, if you're really trying to measure the welfare of the worst off in society, that is to say, measure poverty in some sense, what's the right measure? Is it consumption? Is it income? Is it something else? I want to think a little bit about that. Again, it's beyond the scope of their paper, but it's worth thinking about because they can apply their work to answering the right answer and see. D is I'm going to look at like this paper looks at a particular source of error, but there's a lot of other errors sitting around that we're not thinking about, but it's worth thinking about. So like inflation, PPP, those are going to affect your ultimate estimates of the fraction of population living below $1.90, which is kind of their measure of poverty. The last thing I'm going to look at is stress a little bit. This really is relevant to maybe B and C to some extent, but CPHS is longitudinal data, and it has a lot of value. And we want to think a little bit about trying to mine that a little bit more. In this paper, they try not to do that, except that they kind of treat the paper as a repeated cross section when there's a lot of really interesting longitudinal information on individual households. Okay, let's jump in. So let's talk about the theoretical grounding. And again, I just want to be very clear about this. The paper is quite extensive and sophisticated. This is my effort to try to make sense of their methodology. Hopefully it's enlightening and will allow us to ask some questions about that methodology that are useful. So the first thing is, one way to think about the CPHS, if you assume that NSS is good, and CPHS is a way to think about NSS, then you can think about CPHS as really measuring NSS consumption with error. Okay, and so you might write down an equation that looks like this. And don't worry about logs. This is not going to be critical. I only put down logs here because I'm going to deal with multiplicative error later. And that's something that I think they're doing too. So you can think about log of CPHS as being something like log of NSS, same year, plus some error term. Okay, and there's lots of reasons for that error, by the way. There are sampling differences, questions asked differences, method of asking questions differences. Anybody that's done this, like I've gone out and done several surveys where I say, I'm going to take questions from NSS, I'm going to repeat them in the field, and we get totally different answers. Surveying is a hard art. But so there are many different sources. Now, here's the challenge. We only observe NSS in 2011 and maybe 2017 if you use the leak data. But you observe CPHS in 2015 to 2019. And so the real core problem is I see 2011 for one database, and then I see 2015 to 2019 for the other database, okay? However, we observe some other variables X from CPHS and potentially other better databases, we might think, better than CPHS in the later period, okay? So these are the examples of the databases they look at. And so you might posit a model that says, all right, for those other variables X, it is the case that in fact CPHS measures those with error, those are good. So log of CPHS measurements of X in a given year is equal to the log of the measurements of those other variables by those other data sets in that year plus some error. Okay, so these are two measurement error models, right? Very simplistic, strong parametric assumptions just for the purposes of understanding. All right. So now let's start with the scalar model. So you see how I did it log additive. So this I can just do scalar just to make it a little easier. Let's suppose that my two models then are the consumption from CPHS. So the subscript C is for CPH, subscript N is for NSS, subscript O is going to be for other databases. So I'm going to assume that consumption from CPHS is equal to the consumption from NSS times a multiplicative error. Same thing with the other variables, non-consumption, from the other databases. CPHS measures these other things with multiplicative error. Now, here's the key assumption, I think, of their approach. We're going to assume that UT, the multiplicative error in the consumption, is time invariant, and the consumption, the multiplicative error in the other variable model is also time invariant. And not only that, not only are both time invariant, but they're the same. Okay, before we go on and I explain why this is the case, I want to point out this is very strong. Okay, without this is a very hard matrix completion problem. You can make some parametric assumptions along the way, but I think that's roughly what's going on. At least that's how I interpreted it. There are not a lot of equations in the first two sections of the paper. It comes a little bit later. And so that makes it a little bit harder. So this is my effort to try to understand what they're doing. There are specific examples I can think of where the error for U being different than the error for consumption being different than the error for the other variables, that's violated. So for example, if you use as your other database NFHS, NFHS, the comparison they are using is based on census 2011, whereas NSS is based upon census 2001. Those are different samples. That might be another way why these errors are different. You can also think of situations where The time invariance of the multiplicative error is also violated. So you can think about expenditure growth. You can see that, for example, even in their paper, they show that there's a difference in expenditure growth in the CPHS versus the national accounts. And so that would make this, this assumption right here a little bit problematic. Okay, but let's suppose that you buy this assumption. Let's suppose you buy it. Then what you're really going to do is you're going to say, all right, I'm going to calculate the multiplicative error on consumption as equal to the multiplicative error on other variables, and I'm going to calculate the multiplicative variable error on other variables as the ratio of, I'm being super simplistic about this, right? And this is a scalar example, the ratio of other variables in CPHS in, say, 2019, and other variables in other data sets in 2019. Okay, and then once I do that, once I have this U, I can calculate it for C, because I've just assumed that U and V are the same and they're time invariant. Okay, that's a simple scalar example. Now, obviously, X does not have to be a scalar. You know, maybe you could use X as, for example, I don't know, let's look at, you know, land holdings or something like that. Labor force participation, there's a whole bunch of X's. But reality, they use a whole bunch of X's. They use a whole matrix of X's. Okay, so that varies by individuals I and variables J. And then what they do instead of just doing a simple scalar like this, they assume that there's a function that maps X onto a scalar, okay, for consumption. And they do the same thing for these other variables, okay? And they assume that this, so this is just the variant of this equation right here. They do this for, so they do this for CPHS, then they do it for the other data sets, and they assume that there's this scalar. Now, it's a little bit more complicated in the Jaynes 1957. It's an affine transformation, but that's not really relevant here. The key thing is that there's a simple transformation. You convert from multidimensional to a single dimensional, and then you choose your multiple or affine transformation in a one-dimensional space, and then that's what you're going to then apply to the consumption data from the other data, okay? Now, it's really important to remember that now that you're not just doing a simple comparison of, you know, just X is just scalar, it's multidimensional. Even though you are trying to calculate a scalar multiple or an affine transformation in one dimension, you're going to find that for specific variables J, that the gap is not going to be exactly 0. That is to say, the ratio is not going to be exactly 1. And so you'll see that. And they've got a nice figure too that basically shows what that gap is across a lot of different important variables. So I think that's good. My minor suggestion here is really, instead of showing the gap for specific variables where you're kind of just relying on the reader's prior assumption about how close those variables ought to be or how important those variables ought to be, show me what the scalar, what the V is in my example, or in the terminology in Jaynes in the max entropy world, show me what your lambda and U are. Which is the constant and the transformation, right? And that'll give me a sense of whether that's good. Now, that's going to be really relevant later on, because I'm going to ask you about what X's should you choose. And once you have a choice among X's, which is not like a serious consideration in this paper, then you can say like, well, how do I pick? Like I must have a max entropy metric, like a equation, like something like a goodness of fit that'll help me choose my X's in some way, okay? Now, once you think about this as a matrix, you realize, oh, wow, now this is this was a hard assumption. It's now a little bit more meaty now that I've got the choice of X in there too. Okay, so let me just talk about the implications, then talk about the alternative methodology. So there's lots of assumptions here. There's something like scaling or affine error. The errors are the same for consumption and other variables. You have to choose X very carefully. We need to think about the optimal X selection methods. You know, you have to choose the correct transformation for data sets other than CPHS. There's the Jaynes 1957, but maybe that's not the only other method. There's also a question of not just what X's to pick, but concomitantly what databases to pick. And so there's you know, kind of some depth there that needs to be explored. And I'd like to, you know, be nice to see. First of all, I hate making this comment because this is such a thorough paper. It's very long. It has so much content. My ultimate recommendation is that they break it up into 3 papers so that it can be absorbed easily by readers. But I also would wish that at least in this section, there were some robustness exercises, which might be palatable if you think about this as multiple papers. Now, there are some alternative methods that's out there. You might have imagined that you just apply a simpler approach, which I'll talk a little bit about. You know, just say, let's compare CPHS in 2017 to NSS in 2017. That seems more like an apples to apples. You don't have to use a different X. You don't have to use a different alternative database. I call this the keep it simple principle. You're going to get a lot more faith when in a methodology if you can understand the methodology, even if it's less perfect. There's some credibility there because of transparency. The authors use a little bit of this, do a little bit of this on page 17, but they use it for validation, not so much for the reweighting. There's also a really interesting symmetry problem here, which is here we're trying to contort CPHS to meet NSS, but you can imagine contorting NSS to make it look like CPHS. And it could be that the results are different because the X's that you would use are different because you need to use different data sets back in the early period, which is 2011. Okay, but it's an interesting exercise to think about. I'll talk a little bit more about that when we talk about what's better. Now, there's an alternative methodology. Okay, and this is there are two approaches, and I'm gonna try to get it right. But I would welcome correction because it was a little bit hard to understand. So one approach that they say is, hey, find a bunch of variables where CPHS and NSS overlap. Okay, let's call those Z. Then what we're going to do is we're going to estimate something that looks like the following regression. Consumption in 2011 in NSS is a function of the overlapping variables in NSS. Okay, I'm going to estimate C and B. Then I'm going to predict NSS consumption in 2019, which I don't observe. I'm going to predict what that is using those coefficients times the variables in CPHS that overlap with NSS. Okay, that seems like a reasonable approach. Here's another approach, which I think I understand. This is the third moment stuff that they were talking about. But let's posit the consumption in CPHS at time t is some linear function that looks like this. It's a linear function of consumption in NSS. Okay, kind of consistent with that error model. And then I'm just adding this sigma, which they add in front of the error, so we can get some variation. That's not critical per se, but you do something like this. Now, you can't directly estimate this because, again, time periods don't overlap. So they're going to say, look, let's take a look at some of these moments. There's the mean, the second moment, the third moment. They kind of point out that the third moment in NSS seems time invariant. So that allows us to absorb, just ignore the time subscripts. And then I'm going to estimate the third moment implication of this equation, ignoring time subscripts. And then I'm going to use that to predict. Okay, so that's another way. The only minor suggestion I make, just an editorial comment, please be careful about your time subscripts. It took a long time for me to kind of infer that from the figures that you show. So if you put them directly into the equations that you put into the paper, that'll make it a little bit easier for the reader. Okay, let me try another robustness one. While we're at it, we can try a different approach. Let's suppose that you observe consumption in NSS in 2011. You observe consumption in CPHS in 2019. You observe some other variables from other data sets in 2019. And what you really want is consumption in NSS in 2019. I just picked one date. Obviously, it's 2015 to 2019. Okay. Their preferred method is something like you're going to regress. This is just a slightly more complicated version of what I put before. You're going to regress. I'm going to use that word, a function that maps this multidimensional X onto a scalar. For the other data sets in 2019, you're going to regress that against that same sort of variables in CPHS. Okay, and then we're going to assume that if you do that, this should actually say C, that the consumption in NSS 2019 has that same transformation as consumption in CPHS in 2011. Okay, this is actually should be 2019 over here. All right, but what if you also happen to observe X's from 2011 from other data sets? Then alternatively, you could do the opposite scenario. And this is just like the contortion of making, well, this is not even contortion. This is ignoring CPHS entirely. You could imagine doing the following thing. So let's suppose that you've got some outcome, say consumption of NSS in 2011. You assume that's some linear function, affine transformation of these other variables that you observed from another data set in 2011. You run this regression, and then you assume, oh, well, if that data set also exists later, say in 2019, I can predict consumption in 2019 from NSS using that same regression. Okay, I haven't used CPHS at all. I've just kind of predicted off those other data sets. Now, if you do that, you'll realize the question you'd ask is, well, if I compare their methods to this particular method, right, their preferred method to this method, all I've done is in their method, we use CPHS. In the method that I just suggested, you don't use CPHS. And the question is, Well, which is better? Well, that's really a question of what is CPHS buying you? Like, why do we want to use CPHS other than the fact that we're in a CMIE webinar? That's I think the interesting issue. What is it that you like about CPHS, not just what it is that you don't like about CPHS, okay? And then broadly, you want to step back and say, hey, there's a lot of methods in this paper. Why do I prefer one method over the other, okay? Especially if they give similar results, which they kind of do, because that's the thing that they tell you makes it more credible. Why do I prefer one method to another? So now let's quickly comment on the results. I'll try to make this go fast. And Mahesh, I will trust that you will interrupt me if I'm going too long. So let's think about these results. So this is the kind of the home run figure. That is to say, for those of you that follow baseball, if you're cricket fans, you're not going to appreciate that. This is the goal, the ultimate winning goal picture of the paper. It's a fantastic figure. It really tells you the different approaches that they've got, what it implies over time for poverty. This is great. My first suggestion is please move this up to the front of your paper. This is a very important figure. You need it in the introduction so you can motivate the rest of the paper and you can revisit it later. You shouldn't have to wait to get to page 43 to get this very important message, which I think is the main important finding here. Okay, then I have a smaller question, which is, look, this is like, quibbles about graphing. There's a big gap between 2011 and 2015. This makes it seem like a nice decline. It's really a flat line and then a decline, which tells a different story, which is important, okay? Because the only event here is not just demonetization, but part of the debate is there's a government change during this period. And so that this has implications for that, whether or not one likes that, it is an important way to think about it. So a way to stretch out this figure artificially would be really helpful. The last thing I get from this is, was all this yoga worth it? I mean, look, this is the raw data. Doesn't seem that far off. Yeah, there's some jumps up and down, but I mean, unless you really, really care and you're looking for narrow changes, doesn't seem so bad. So my takeaway from this is, it wouldn't be that bad. Okay. Now, obviously, I don't know where this is exactly coming from. If that's just the NSS data and then everything else is CPHS, it doesn't seem as bad as people might worry. By the way, one thing I really like about this is that it's very hard to understand this paper and like worse than we thought, because that part of that explanation of what we thought comes later in the paper. But here I like this paper too, because it tells you what we thought as the decline. Okay, so this is a great figure. Okay, so now let's get to top comment number B. Does NSS or CPHS measure consumption better? Okay. And so one really, just here's a simple example of why I'm not 100% sure about this. I know that part of the answer is just like people trust the NSS. That's what people have done. I'm newer to this debate, so for me, that itself is not a sufficient reason. I'd like to actually objectively think about why one approach is better than another, but let me give you an example. So NSS uses the 2001 census frame. CPHS uses the 2011 census frame. A key issue during this period, which the paper highlights, is that some villages from 2011 become towns. There's growth, right? Population growth in these places. Now, let's suppose that we think that the towns that switch, so the villages that switched from villages in 2001 and that become towns in 2011 are the richer villages. Just assume that, people live in agglomeration economies, maybe that's not an unreasonable assumption. Okay, but if that's true, then what that tells you is that the 2001 frame, which is the NSS frame, has lower rural and higher urban poverty than CPHS. Now, I don't know if that's exactly true. You have to do some validation, but that shift in the frame makes you think about whether or not the comparison, whether you really want to get apples to apples, or let me put it another way, whether you really want the target to be NSS or you want the target to be CPHS. Okay. Now, I'm going to ask, I think, what seems, in my experience, to be a somewhat verboten or ignored question is, do we think that NSS, NFHS, other government databases are actually done correctly? Okay, I generally think about people talking about this in hushed tones. Look, let me stand back and say, if you look at state capacity in India, we don't hold out India, with all due respect, as the paragon of state capacity. There are lots of government programs that are not run well. Why is it that we think that data collection is done well? I mean, I understand that there are extremely smart world level statisticians involved. But having statisticians that are sophisticated and having a very sophisticated sampling methodology is not the same thing as good implementation. And anybody that's been out on the ground and hired surveyors or tried to get things done or do back checks realizes this is a very difficult problem. It's not obvious that the government's doing a great job. So I would at least say, let's put NSS and other government databases and say private databases like CPHS, at least potentially on the same, kind of a priori not knowing, not make an assumption about which one is done better. Also, another issue is, look, maybe they're just different and they have different approaches and there's no clear right answer. And so maybe we want to do some mix of them. I think that's an untheorized view, but it's not a novel view. Okay. Now, let's also ask the question, should we be looking at consumption when we're measuring poverty, or should we be looking at income or something else entirely? Now, when I think about this, I think about a multi-period model. When I think about each period, I think of having an individual household having the following budget constraint. Your consumption plus your savings has to equal your income, that period flow income, plus your, I'm just calling it D for dis savings, okay? And then I've got some asset equation where my assets tomorrow is equal to my savings plus the rate of return on those savings, plus my assets the previous period minus anything I take out, the dis savings, okay? And you can impose various constraints. You can say there's no insolvency over the course of your life. At the end of the last period, you have to have a positive amount. And you can also then introduce, for example, borrowing frictions and just say that, D has to be always less than AT in each period. So you can never go into a negative balance. Okay, no net indebtedness. All right. Now, if you think that consumption poverty is declining over time in a context where you get some intertemporal substitution like this and pretty good, if you think it's declining over time, it has to be that you think that there is some real purchasing power parity adjusted income growth, but either that growth was surprising, so you didn't smooth it out, or people can't borrow, so people didn't smooth it out. Okay, so it's very simple stuff, right? Otherwise, there wouldn't be really a change in consumption poverty. Now, if we assume realistically that there's imperfect capital markets, lower consumption today actually means higher consumption either earlier or later, okay? Because you got to do borrowing and savings. And then that's going to depend on the timing of income. And that itself will affect growth. So growth in consumption measures income growth, expectations, and capital market frictions. I think I'm just restating what I'm saying at the top of the slide. Now, that's not really a problem if there's no actual borrowing and savings, but in fact, we see a lot of borrowing and saving in CPHS. So this is from a paper with Arpit Gupta and Bartek Voda, where we're regressing. This is looking at, say, 2019 and 2021. We're looking both pre-COVID and post-COVID. And we're looking to see, we're just doing a standard Townsend or Cochrane-like consumption smoothing regression. Left-hand side is your consumption. Right-hand side is typically income. So you might look at something like this column. And now we're going to do it separately, not separately, but interacted with what quartile you're in. And one of the things that you learn is that the marginal propensity to consume, if you're ignoring the role of aggregate shocks, is something like 13%, not far off from Townsend 94. Okay. But if you control for aggregate shocks, the marginal propensity to consume is like 10%, which is actually much better, which means a meaningful amount of smoothing. So when we think about shifting consumption here or there, it seems to be happening, maybe even in a marketplace in the sense that you're borrowing and savings. Okay. What's also super interesting about this is not a feature of the rich. In fact, there's very little differences across quartiles during this. And in fact, it changes very little even during the pandemic, which is surprising. At least it was to us. And what that tells us is the consumption stuff is you got to think about it in context of the income as well, or at least that income is a good measure of this as well. Okay. All right. So maybe income poverty is a better measure of poverty in the context where you can smooth. It could be, you could argue that CPHS measures that better since it has income data. There's a very small point here that I'm going to make is that when the authors actually, so NSS is a whole year. To get that for CPHS, you have to take 3 rounds. A round is 4 months. And if I understand correctly, the authors randomly pick for each household one of those rounds. In fact, maybe it's better just to take an average of it, at least. That's a small nitpick. Now, you could say in response, income is hard to measure. I'm not even sure even CPHS measures that really well. I'm going to look at assets, but I want to be very careful about this. Assets are easier to quantify, but they're harder to price, especially when there's macro changes going on. And that's maybe your reason to look at consumption. It's just better than income and maybe even better than assets to look at. But here, now you're stuck in a rock and a hard place. The consumption poverty stuff is kind of, the intertemporal changes are kind of messed up because you have this consumption smoothing, so that makes consumption not that great. And you have to compare that to like poorly measured income. So I'm not saying there's a clear answer. I'm just saying it's worth thinking about how we want to measure poverty. This is not a new debate, so I'm not really saying anything really dramatic here. Now let's look at some other errors that are out there that are perhaps as important. Remember, we've got this metric, less than $1.90 per day. You can do it in consumption or income or something else, but let's say we do it in consumption, but we have to do real and purchasing power parity adjusted. And that means that not only do we have the error of going from CPHS to NSS, but that you also have the issues with inflation measurement and PPP measurement. And we know that there's lots of problem with inflation measurement. There's lots of problem with inflation measurement in developed countries. You might imagine that there's problems in low and middle income countries. Okay, are we picking the correct baskets? Are we making the proper quality adjustments, especially in a period where, like I do a lot of work in slums. You go to the slums in 2011 and you see very few cell phones. You go to the slums in 2019, you see a lot of cell phones. You go now, you see even more cell phones. How is that included in the consumption basket? I just want to learn about a lot of stuff. I want to think a little bit harder about whether or not the errors in inflation and PPP are bigger or smaller or comparable to the NSS to CPHS gap. Okay, now, last thing I'll say is let's talk a little bit about the longitudinal aspects of CPHS. We already talked about for poverty, intertemporal substitution. For inequality, there is some data on the raw CPHS that was that's in this replicated here, figure 16. You see what the Gini coefficient looks like. I think one of the things that's interesting about this Gini coefficient is, and I think Amol is on the call, one of the things that I find kind of interesting is just to get them to talk a little bit about the fact that CPHS might be showing a jump right here, but that's a separate conversation. The point that I want to make here is that, look, when we think about consumption inequality, when you have longitudinal data, you can look for each particular percentile and the changes over time, okay? Or a particular household and changes over time. And you can decompose a particular household's changes over time into that household's change in percentile plus that percentile's change in the share of income, okay? And so a simple way to put that is you can think about consumption inequality and when you have longitudinal data as the sum of social mobility and a Gini coefficient, okay? And we elaborate on this in our paper. And so what's really interesting is to try to kind of show using CPHS what those two components are. There's a lot of focus on Gini in this paper, and the reason is because you're taking NSS as your benchmark, which is a cross-section, and then trying to treat CPHS as a repeated cross-section. But that ignores the social mobility that you can unpack from CPHS. And so you can see that, for example, in our paper, again, the time spans are different. I can't compare to 2011, which is the big insight of this paper, but you see that over time, if you look at individual households, you'll see that consumption inequality, and here we're doing this income inequality and consumption inequality, we're doing this by household normalized by 2018 income. So it's an index of 100. We're basically showing that inequality in income is declining. This is by the way, it starts in 2018. This is the lockdown. This is the post-lockdown period. The pandemic starts at the blue line, and you see that inequality is this green line is 1 minus 4 rather than 4 minus 1 in terms of quartile. So it's inequality is starting to decline. We're getting progressive changes with this green line that starts in 2018. You can see that also in consumption, but you can break that down into parts. If you use the longitudinal data that's in CPHS, you can look at, for example, the Gini coefficient, just as the authors do, and you actually see very few changes in Gini over time. But if you start looking at, for example, social mobility measured by Sharrock's index or directly by measuring social mobility as changes from top quartile to other quartiles, you see big changes over time. So a lot of the activity is happening in social mobility. Going for repeated cross sections might be missing some of that. Okay, that was a lot, I think. That's because this paper has a lot. So far, I've only commented on I would say maybe 3/4 of the paper. I stop on page 47. There's 16 more pages of comparisons to other data sets. This is a truly impressive paper, just showing that you should believe what they're saying. Again, my suggestion is, I don't have the capacity the authors have to do this much analysis and absorb it. I really wish that last section were pushed to an appendix, or even better, let's break this down into 3 papers that are absorbable. I think that'd be really great. I look forward to hearing from them a little bit more about mechanisms in another paper. That I think is really exciting. Arpit and I are looking exactly at this issue. One of the really interesting things here, looking just at CPHS, not NSS, is that we find that inequality did not rise during demonetization. We need to reconcile which are right to some extent, but we find that the inequality starts declining before the pandemic in 2018. And we think that that's an interesting debate, I think, next to have amongst the folks that are in this literature. Our hypothesis is simply that what's going on is it's not demonetization. Demonetization shifted the portfolios of the rich, so that they moved into shadow banking, and then there was a shadow banking collapse in 2018, and that's what caused a contraction of inequality. That's our hypothesis, but it's worth discussing, and we look forward to continuing this conversation. So this is just a figure that focuses in on the income inequality and showing that there's a change starting even before the pandemic. Let me stop with that. I feel like I've taken up more than my time, but I look forward to hearing from the authors.
Thank you, Anup. That was a very thorough, detailed, and pertinent presentation and discussion. I think I would do best to pass the mic on to Sutirtha and Roy for them to respond to you, please.
Thanks a lot, Anup. This was a tour de force. First of all, thanks for taking so much time to read through the paper with such careful attention. It's full gratitude to you. And I think I made some notes, but I think what would really help is if we can access your presentation, especially look at the equations a little bit more careful attention and pay a little bit more go through it in more detail. Let me see if I can recall some of the points. I made some notes, but okay, let's start with the last one that you asked, which is about mechanisms. So I think this is very much on. I think your comment is very timely. I think the plan, our idea is that once we have an understanding of the consumption vector itself and the numbers around poverty, the natural next question is to then think about what's driving those trends. So looking at the drivers of what's causing that fall in poverty is definitely on the cards for us, and that's something that we wanted to pursue, and it's great that you have highlighted that. Another thing that we do want to do, as you would have noticed, that we stopped in 2019, 2020 with this. Our thinking is that once we have some benchmark surveys to reweigh, or actually, let's not assume that we will have to reweigh 2020 onwards the CPHS, but do the exercise of whether we detect sort of the biases that we have observed between 2015 to 2019, whether those are persistent, and if they are, then we'll need a benchmark survey to be released by the government to then to update the weights. So those are the two things that we are hoping to do. You asked a meta question, so let me deal with that. So what is it that you like about CPHS? Why are you doing all this yoga? I mean, why do you? So I think one thing that CPHS has been able to do, although there are many NSS surveys, and we could do apply approach one to several different types of NSS surveys, and we do that using PLFS. But the one thing that we like about CPHS is that there is a consumption aggregate. It's based on 115 questions. There are differences between the CPHS consumption aggregate and the NSS 2011 consumption aggregate. But at least there is a household consumption value that we can use to then implement approach 2. Approach 2 will not be applicable on any other data source because no other data source has a consumption value. So that's something that we really like. The other point that I would like to make is on approach 1. One of the so if you look at the comparisons that we make between PLFS and CPHS in our validation section, we find that having asset variables is a very important predictor of the left-hand side. And so PLFS does not have that. So even to implement approach one, I think the availability of asset information in CPHS really is something that we value. Your points on 2011, 2015, keeping a gap there is I've made a note of this. This is the second time somebody has pointed it out to us, and definitely in the next iteration we will be updating that. Time scripts, very, very useful. And then I have some technical notes, but before I sort of get into the technical notes, just make sure that also Roy has had a chance to reflect on your comments, and then we can sort of, maybe if we have some time, just talk about a little bit about the equations that you noted down and our interpretation of those.
So also for me, a really big thank you, Anup. As that was a very thorough and impressive job as a discussant. Yeah, so there's so much detail and also so many excellent technical comments. If you would be open to it, could we maybe touch base with you in the near future and sort of interact and sort of work out some of these technical details? I'm not sure this is the right time and place to sort of go through the really technical intricacies that you highlighted. You also asked the question, is the CPHS or the NSS sort of the right consumption sort of data to work with? You mentioned the alternative of, rather than converting CPHS into NSS, we could also convert sort of the NSS into CPHS. So the first thing is, the reason why we sort of did this effort is, and then we made this effort to convert CPHS to NSS, is precisely because we wanted to assess how poverty has evolved over the last 10 years. And so the only way to do that is to convert at least one into the other. So either we have to convert indeed the CPHS to NSS, or to convert the NSS to CPHS. That's the only way that we're going to be able to sort of evaluate how poverty by some sort of has evolved over the last 10 years. So it would allow us to make an apples to apples comparison. It so happens that the NSS underlies India's official estimates of poverty that have also been embraced by our institution. And so converting the CPHS into NSS seems like the logical first step to consider. It's also less work to sort of convert the CPHS rather than going back to all the previous NSS rounds and sort of convert those. But in principle, you're right. And Sutirtha already highlighted some of the advantages of the CPHS, which we very much appreciate. The fact that it has indeed a consumption expenditure questionnaire. It collects data on household asset ownership. The other clear advantage is what you highlighted as well, is that it's high frequency. It's the one survey that gives us data every 1 year, and it's available relatively quickly. So I think, and I imagine at some point we'll be in a situation where the sampling has settled down. The weights, there will be less and less need for reweighting exercises. In which case, those advantages of having like high frequency data that are made available quickly becomes increasingly more appealing. So at some point, you noted somewhere that the reason why we cannot sort of estimate the relationship between CPHS and NSS consumption because we don't observe them in the same year. I just want to note there that even if you did have a CPHS survey and it's supposed to hypothetically that we had an NSS in 2019, then we can still not estimate that regression readily because these households cannot be linked, right? So that could only work if the NSS households from 2019 and the CPHS households were one and the same and they could be linked. But that's not the case. These are two sort of completely independent cross sections that draw their own sample of random households. And so it wouldn't give us a sample of households for which both of these consumption measures would be available. So even if we would have a contemporaneous NSS and a CPHS survey, we would still not be able to run a simple regression. We would still need something like a method of moments approach to estimate the parameters of that relationship. I mean, yeah, so the other comments I had are sort of more technical and I mean, I'm happy to go into some of the details, but I think I feel like it might be more appropriate if we would take that sort of discussion offline, unless the also in the interest of time, but also yeah, I think this may not be the right place to delve into really technical details. Want to add something?
No, I think that's
No.
it.
I think, Roy, you are right. We have achieved the objective of this webinar, the multiple objectives we have. One, which is to take your work to an audience that will appreciate your work, and to have a discussant who can, bring in technical observations to help hone the work that you have done already. And I think Anup has done a wonderful job in that. I think it is ideal, it would be best for the authors and Anup to connect and work out the details further. We have overshot our time just a bit, but if there is any further interest from the audience, I would be happy to entertain that. I don't think there are any questions which are outstanding. In case Roy, you would like to entertain any of the questions, you may do that. We can give 5 or 7 minutes more to that before we wind up. But I think it's great for Anup and you people to connect afterwards. Anup, I hope that's okay with you. Thank you. I think I'm interrupting, Roy. If you find any of the comments worth interacting with afterwards, we can share the email IDs of these people with you, and then you can connect with them as well. Sutirtha?
I think it's a good suggestion, Mahesh.
Okay.
Let's adopt that.
Okay. So you can carry this conversation further ahead. So
Yeah.
all I will say is thank you, both of you, very much for making this presentation, for writing a wonderful paper, for really putting CPHS under the scanner. I should thank you for that. And that's a very, very important piece of work. Like Anup put it, it's a great public good that you have done by putting across the methodology on how you can make reweight this, etc., etc. So with that, with your kind permission, I will say we will. Roy, do you have anything?
I wanted to highlight, I don't know if that is known to everyone already, but we have 2 days ago made the adjusted weights available in the public domain. The link to the might be available
in the presentation.
In the presentation. So anyone can download the adjusted weights that we produced.
Okay, that's very useful. Thank you so much. We will make that available. Let it be known to the public at large as well. So Sutirtha, we have your presentation. We will make it available publicly. Anup, if you could send us your presentation, we will also make that available publicly. And if you have your latest paper, Sutirtha, can you send us that as well? We will make that available publicly as well. So with that, thank you everyone very much for being a part of this presentation webinar, and look forward to seeing all of you again in the next one. Thank you.